happen to have the notes printed, I'm actually going to skip this first section to keep things as simple as possible. It's like an intro problem, and we're just going to skip it. And I do want everyone, though, if you're copying notes by hand, I need you to copy these steps down, and I'm going to give you a few minutes to do that. These are the steps I'll be using. Let me zoom out a little so you can see the whole thing. So I'm going to give everyone a few minutes to copy these down, and then we will proceed. If you're watching the video asynchronously, pause your video right now if you're copying notes by hand, and don't start it again till you have all the steps written. I'm going to be using these steps for the rest of the lesson. So when I'm putting down like S1, S2, I'm talking about these things. All right, so here's our first problem. 2 over m minus 1 over m minus 1 equals 4 over m squared minus m. Let me give you a second to write that down, and then I'm going to show you some stuff to set up the problem, but you're not going to need to write it down. Okay, this stuff I'm about to write down, I don't want you to write down. I just want you to look at your screen and listen to me for a second, okay? Pretend instead of this entire equation, I just had these parts. I just had 2 over m and 4. Again, you're not writing this down, you're just listening. So let's say I had this equation. What you would do to solve that is you would start by multiplying both sides by m. Okay? The reason is because you need the m out of the denominator. And it would cancel here. And then you would have 2 equals 4m. And see, there's no more fractions now in the next step. This is what we're going to do in our equation. It's just that there are 3 denominators in that equation that we have to cancel out, not just 1. So we're going to cancel each one out, and it's going to be a multi-step process, okay? But this is the basic idea behind what we're about to do. So let's do that. But the first thing we need to do is factor each of the denominators. That means break it up into factors if you can. Remember that factors are things that are multiplied together. So when I look at 2 over m, and I'm going to factor the denominator, I can't, because m is just m. I could write m times 1, but the 1 is not significant enough to separate out. In the second fraction, I cannot factor m minus 1 because the terms don't have a GCF, and the m minus 1, they're not factors. They're being added and subtracted together. They're not being multiplied, so there's nothing else that we can do there. And then on the third fraction, I can factor the denominator. M squared and negative m, they have a GCF, so we can rewrite this as m times m minus 1. And so here's step 1. We factored all the denominators, okay? Step 2 says to multiply every single term by the LCD, or the least common denominator. And I'm going to show you how to build that up step by step. I'm going to rewrite this so that I have space in between each one, because I'm about to add some stuff. The LCD is built from each of the denominators. So for example, on that first fraction, just like that intro problem I gave you, In order to cancel out the m in the first fraction, I need to multiply that term by m, which we talked about already. But in this equation, you can't just multiply one thing by m. You have to multiply all of the things by m to keep the equation in balance. And that m would cancel out that first denominator. But it doesn't cancel out the second denominator, the m minus 1. This is a group. So let me show you something that's bad math, okay? This is a bad math alert. Bad math alert. So I'm going to do this in blue, and then I'm going to erase it because it's bad. This does not work. Watch when so put your eyes on the screen, on the middle term. This m does not cancel out this m. The reason is because you can only cancel out factors, meaning you can only cancel out stuff that's being multiplied. But this m right here is being added to a -1, not multiplied by a -1. So that red m does not cancel out that m on the bottom. So here's what we do instead. We make this an entire group. Okay, so in order to cancel out that denominator on the bottom, we're going to do it as a group, m minus 1. So that's how you cancel out stuff that has a plus or an addition or subtraction in it. You have to treat it as a group. But you can't just multiply that one thing times m minus 1. You have to do all the things times m minus 1. And when you go to look at the right-hand side, the 4 over m times m minus 1, if you notice, you actually, those things are already going to be canceled because look what's going on. So everything on top, 4m and m minus 1, those are all factors. They're all being multiplied together. So you can cancel them. So on the right-hand side of your equation, the red m on top cancels out with the black m on bottom. And the blue m minus 1 on top already cancels out with the m minus 1 on bottom. There's nothing left in the bottom on that right-hand side. So you don't have to multiply everything by anything to take care of that part. In the middle, though, so going back to the 1 over m minus 1, these canceled out. So we're going to clean this up because there's stuff everywhere. So what's left over, oh, let me zoom back in. Sorry, I had changed the zoom when I was trying to get the steps all on. Let me make this bigger. So go back to the front of your equation with the 2. What do you have left there? You still have a 2, and you still have an m minus 1. Those things did not get canceled. And then minus is the next part of the problem. And what didn't get canceled there? You have a 1, and you have an n. And on the right-hand side, all that's left that wasn't canceled was a 4. And so this is a much easier equation to solve than the original one. So what we've done is we've cleared the denominators. And then step 3 is to distribute and combine like terms. So that's what we're going to do next. Distribute this 2 m minus 2 minus 1m equals 4. Combine the like terms, the m's. So 2m minus m is a 1m. Add 2 to both sides. m equals 6. And this was our step 4, solve for the variable. Now, normally when we're done solving, if there's ever any more steps on your notes, it's usually like, check your answer. And we just kind of blow that off and pretend we didn't see it, right? Who wants to spend time checking their answer? This extra step here, though, is not a negotiable. You have to do it, and I'll tell you why. So step 5 says to exclude extraneous solutions that make a denominator equal to 0. The thing is that you cannot divide by 0. It's called undefined. So when you go up, and this is what a rational equation is, it's not the fact that, because remember that word rational means something that can be a fraction. So these aren't called rational equations just because they have fractions. Like it could have a 1/2, but we wouldn't call it a rational equation just because of that. What's going on here is that there are variables in the denominators. That's why they're called rational equations. And because we just solved for the variable, we said m is 6, we have to check in each of the denominators that after you plug it back in, that it doesn't make any of them 0. So obviously, and so we have to do each of the 3 fractions. So in the first denominator, there's an m. And when we plug in 6 for that, we just get 6, right? It's not 0. It checks. It's fine. When we check out the second denominator, which is m minus 1, so we plug 6 in for m and make sure we don't get 0, which we don't, so it's good. And then we check the last denominator. Plugging 6 in gives me 6 squared, or 36, minus 6, not 0. Okay, I actually don't care what the numbers are. I just care that they're not 0. So it's all good. So I have 6 for my answer. So here's your next problem. 4 over 2y minus 3 equals 7 over 3y minus 5. You want to first start by checking if you can factor any of the denominators. So we have 2 denominators. We have 2y minus 3, and we have 3y minus 5. And neither one of them can be factored. Okay, so step 1 is not applicable. And the reason is because if you're looking at 2y minus 3, there's no GCF. 2 and negative 3 don't have anything in common, and they don't have any y's in common. Same thing on the right-hand side. 3 and negative 5 don't have a common factor, and they don't share any y's either. So you cannot factor 2y minus 3 and 3y minus 5. Okay? So then we just look at the next step, which says to multiply by the LCD. And the LCD is all the pieces you need to cancel out all the denominators that you have. So, okay. So on the left-hand side, to cancel out 2y minus 3, notice that there's a subtraction in there. Because of the subtraction, you have to treat this as a group. So to cancel it out, you use the entire group. And you multiply that to both sides. And it cancels out on the left. On the right-hand side, the denominator is 3y minus 5. It has a subtraction. So because it has a plus or minus in there, you have to treat it as a group. So you multiply both sides by that group. And it cancels out on the right-hand side. And then here's what we have left. So on the left, we still have a 4, and we still have a 3y minus 5. And on the right, we have 7 and a 2y minus 3. And that's where the shortcut, where your butterfly method comes from, if you remember that. 4 times 3y minus 5, 7 times 2y minus 3. That's where we get that from. And now you do, so I'm going to let you finish solving yours. I'm going to solve mine, and then we'll compare. So it's just a regular equation from here. So I'm not going to narrate while I work, so you can have quiet and think. So the answer to the problem is 1/2. Please be sure that you do this last step, step 5 of checking that your solution does not make any of the denominators equal to 0 when you plug it in. And then work this problem, work this problem on your own. And if you're watching the video asynchronously, please pause now to work it. Step 1 is to factor the denominators, and the only one that really you can do anything with is the last one. You can break it up into x times x, because that's what factors are, things that are multiplied. So 5x is already 5 times x, 2x is already 2 times x. So those are already in factored form. So then step 2 is to multiply by the LCD, the least common denominator. The way you build your LCD is from each of the individual denominators. So give myself some room. What I need to eliminate the first denominator is a 5x. And I need to multiply everything by that. And so that will eliminate that 5x right off the bat in the first fraction. But look at what's happening in the second one. I have a 5x now in the numerator. I have an x on top and an x on bottom. So guess what I can do here? Cancel those out. So now all I need to eliminate in that middle term is a 2. So I'm going to multiply everything by 2. And those 2's in the middle cancel out now. And then on the right side of the equation, that one red x on top can cancel out one x on bottom. And the 5 and the 2 don't cancel anything out on that side, but I'm left with one x down there. So to cancel just that one x out, I need to multiply by x on top there. And because I had to do it on that side, I have to do it to everything else as well. And so that x on the right that's on top cancels out the x on the bottom. So my LCD ended up being the red stuff, 5x, times the blue stuff times the green, or 10x squared. So let's clean that up a little bit and see what we have still remaining. In the first term, we have a 3 still, and a 2 and an x. And then minus. What do we have left in the middle one? We have 1 times 5 times x. And then on the right, we just have 1 and 5 and 2. So step 3 is to distribute or multiply everything and combine like terms. Six x minus 5x is x equals 10. Step 4 is to solve, but it's already solved. And remember, step 5 is not optional. You have to check that 10 doesn't make any of the denominators in the original problem 0. So here was the first denominator that we need to check, 5x. When I plug 10 in, I get 50, which is not 0, so that's good. The second denominator is 2x, and when I plug 10 in, it's good. I do not get 0. And the third denominator was x squared. When I plug 10 in, I do not get 0. So it checks all the denominators. I get x equals 10. I need to know. Does anybody need this up anymore? Okay, we are done for the day. So if you're in Zoom, you are free to go. If you don't need to stay behind and ask me about grades or anything. Have a wonderful day. Oh, I already said you could go and everyone dropped out. But there's 2 homeworks. Do one today and one tomorrow, so you don't have too much at one time, okay?